Why does this truck have two steering wheels? Not one, two. And the second one isn't even mounted next to the first. It's on the side of the cab, facing a completely different direction. The driver isn't even looking forward anymore. He's turned sideways, watching something behind him. 300 tons of machine moving at walking speed through a city street. And somehow, one steering wheel can't handle it. Is it broken? A design flaw? Some kind of backup system? No. Because at this size, the truck stops behaving like a normal vehicle. And if the rear wheels miss their line by just a few centimeters, the transport stops completely. Because once a truck reaches this size, normal driving rules stop applying entirely. To understand why, you need to understand what this truck is actually carrying. This isn't a normal freight run. There's no pallets, no containers, and no standard cargo. This is oversized transport. And the loads are almost unbelievable. Wind turbine blades, longer than a football field. Transformer units, heavier than a blue whale. Bridge sections, mining equipment, industrial boilers the size of a house. These aren't objects that fit on a truck. They are the transport. The load and the vehicle become one single moving structure. That changes everything. A normal truck turns by rotating the front wheels. Simple, predictable, the trailer follows. But when your load stretches 60, 80, sometimes even over 100 meters behind the cab, the trailer just doesn't simply follow anymore. It has its own momentum, its own direction, its own problems. Watch what happens when a standard truck tire turns a corner with a 50-meter load. The front wheel turns left, the cab moves left. But the rear of the trailer swings wide, dangerously wide. It climbs up sidewalks, it clips signs, it blocks entire intersections. And that's just a 50-meter load. Now imagine 80 meters or even 100 meters. Moving through a city center, at night with police escorts blocking every intersection. Suddenly, one steering wheel at the front of the cab just isn't inconvenient, it's not enough. But that still doesn't explain the second steering wheel, at least not yet. Here's where the real problem starts. When a truck this size starts to turn, the front wheels respond instantly. The cab moves. But 30 meters behind the driver, the trailer reacts completely differently. It doesn't follow the same path. It cuts corners, it swings out, it scrubs sideways across the asphalt. This is called off-tracking. And on a normal truck, it's manageable. On a 100-meter transport, it's a serious engineering problem. Think about it this way. The front of the vehicle follows the road, but the rear axle, sometimes 20, 30, or even 40 meters behind the last steering point, they take a completely different path. A shorter path, a more aggressive one. And the longer the transport, the worse it gets. Watch the rear wheels during a tight turn. They don't follow the road, they cut straight across it, over curbs, through lane markings, into the path of other vehicles. And there's another problem. Axle scrubbing. When a rigid axle is forced sideways through a turn, the tires don't roll, they drag. That creates enormous resistance, heat, and wear. And on a fully loaded 300-ton transport, that resistance becomes a force that can physically push the trailer off its intended path. The driver feels it through the cab, a pulling, a resistance, a warning. And at this point, the driver realizes something's not quite right. Turning this machine isn't just about the front wheels anymore. The trailer itself needs to be steered. Actively, independently, and precisely. But how do you steer something that's 80 meters behind you? And that's exactly where the second steering wheel comes in. This is where it gets complicated and fascinating. Because the solution engineers came up with isn't simple. It isn't one extra axle that steers automatically. It's an entire second control system built into the transport itself. Let me start with the basics. Modern oversized transports use modular trailer systems. These are trailer units connected together, each carrying part of the load. And each module has its own set of axles. Sometimes 4 axles, sometimes 8, sometimes even more. Each axle group can rotate independently. Not automatically, not randomly. Precisely on command. And someone has to give that command. That's where the operator comes in. On smaller oversized transports, the rear steering is controlled electronically. Sensors read the turning angle of the front cab. The rear axles compensate automatically. It works up to a point. Getting the trailer wheels to follow the exact right path through a tunnel entrance, across a narrow bridge, around a city intersection with buildings on all sides. That's the real challenge, and it requires direct human control. Watch a rear operator during a difficult maneuver. He isn't watching the road ahead. He's watching the wheels underneath him, counting centimeters, calling adjustments in real time. Left, stop. Right, hold. The front driver responds. The trailer bends because, yes, on the largest of transports, the trailer itself articulates, and the rear wheels follow a completely different arc than the front. A controlled arc, a precise one. Now, watch this. A 94-meter wind turbine blade being transported through a mountain town in southern Europe. Streets designed for cars, for delivery vans, for normal life. Not for this. The front cab enters the intersection first. Slow and deliberate. The rear operator calls the angle. The trailer axles begin rotating independently, and the blade, longer than the street is wide, starts to arc. Perfectly, precisely. 5 centimeters of clearance on the left, a building wall on the right. The front driver holds the line. The rear operator makes a micro adjustment. 3 centimeters now. The spotters go silent. Everyone watching the same thing. The gap between the blade tip and the corner of the building. 2 centimeters. The trailer bends, the rear wheels pivot, and the blade clears. By less than the width of 2 fingers. Nobody celebrates, they just move forward. Because there are 14 more intersections before they reach the wind farm. And each one is different. Each one requires a fresh calculation, a fresh set of adjustments, a fresh moment where everything could go wrong. This is what oversized transport actually looks like up close. Not impressive from a distance, terrifying from the inside. Let's go back to the beginning. That second steering wheel. Now you know exactly what it is. It's not a backup, it's not a malfunction, not a quirk of design. It's a completely separate control station built for one specific purpose: to give a human operator direct control over the rear of the transport. Because at a certain size, the front of the vehicle and the rear of the vehicle become 2 different problems, and they need 2 different solutions. Thanks for watching. I'll see you in the next one.